Hello, everyone, and welcome to another edition of Thought Leaders Live, where we talk with thought leaders in business, life, and all points in between. Today, we're talking with Bryan DeBois. Bryan is the Director of Industrial AI at RoviSys. They are a leading global systems integrator for manufacturing and industrial automation. And Bryan helps manufacturers harness the power of AI, machine learning, and advanced analytics to drive innovation and efficiency. What a great topic, and what a topic that really needs some thought leadership in today's day and age. So, Bryan, thank you so much for joining us today.
Yeah, thanks for having me, Greg.
Okay, tell us a little bit about your personal background, your journey, and then what RoviSys does.
Yeah, for sure. My journey starts back at the University of Akron. I was born in Northeast Ohio, and RoviSys is headquartered out of just south of Cleveland, Ohio. And so I was at the University of Akron. I was studying computer science and just went to a career fair and met RoviSys there, really knowing nothing about the manufacturing space. And came into it. And that was 25 years ago. And I've been at RoviSys ever since, and really have fallen in love with the manufacturing world. I've become a real big advocate for manufacturing. I think it really is the lifeblood of any economy. And I think that we're in some interesting times now, which we can talk about in manufacturing. Started at RoviSys, and I was writing custom software primarily for these manufacturing and industrial customers, and then kind of worked my way up. And then in 2019, RoviSys had our 30-year anniversary, and we really looked at the industry. We said, look, we know how to do control system automation, and we know everything about the plant floor, and been there, done that, and we'll continue to do that. But we said, what's next? And we looked at, the up and coming trends in 2019. And so we actually started 3 new divisions in 2019. One was industrial networking. So this was taking all of that knowledge about IT networking and cybersecurity and bringing it to the plant floor. The second division was MES. So these are manufacturing execution systems. These are big software systems that we use on the plant floor. So we got a whole division that just does that. And then my division, which was industrial AI. And I was fortunate enough to be named the director of that division. And what was interesting, when I started this division, was one of the first things I had to do was really bring myself up to speed on what the state of the art of AI was, particularly in the industrial space. So when I was in college, neural networks were kind of passé. They were on the out at the time. And what was in was rules-based systems. And everyone was saying that, rules-based systems were going to be the thing that was going to bring us into this artificial general intelligence, into this next phase. And so that was what I had learned.
Second, Bryan,
Yeah.
pause it for a second. Rules-based system. What do you mean by that?
Yeah, so that's where, and again, this has gone out the window. Like neural networks are back as the primary way of building these ML models. But back in the late 90s, when I was in school, a rules-based system was where you would define all the rules at the most simplistic elementary kind of level. And then effectively you had a system that could evaluate all those rules. And really it was to provide decision support. So you can imagine a diagnostic system for a health, type of situation. Like, well, the same questions your doctor would walk you through. You could write all those rules. That was the idea behind it. Same thing with a business system. You could write all the rules around purchasing, and then it would follow those rules. It did not bring the results that people expected and wanted around AI, but that was the big thing. And then, here I am in 2019. Now, at that point, this is 3 years before the advent of ChatGPT.
Yeah.
And so really I'm looking at, okay, what's the state of the art? And what I found was that we were not early. Let's put it that way. We were on time. I was talking to customers. I started talking to customers, and many of them already had data science teams that they were starting to build in 2019. And they were just starting to dip their toe into some of these AI projects. And so I was able to identify what AI looked like at that time. And then of course, November of 2022, ChatGPT is released on the world. And then my phone starts ringing off the hook, because now every executive wants to talk about AI and how it can apply in the plant floor.
So just take me back a second, one more clarification on the rules-based approach versus the neural network, and how do those contrast? Because like you said, the rules-based, I'm like, well, that sounds like what you would load up in the ChatGPT.
Right. Yeah. I mean, rules-based had its place, and there's still, there's still constraint based optimization that we can do, and and it plays a certain role in this. But the reality of it is neural networks have way outperformed all of that stuff. So neural networks are effectively they're a universal approximator, I think is what they call it. So effectively, a neural network can approximate virtually any function. And so with that, it's able to, we can build all kinds of things on top of that neural network, and it has a much broader space of being able to approximate the answer to problems. And so that's become the dominant form. And so we use that primarily for a lot of the AI projects that we end up building.
Okay, let's this is great groundwork and ground rules for us, especially the novice such as myself, in terms of AI and IT and systems integration, everything you're talking about here. Let's go a little bit deeper now, because we were talking before the call, and I think maybe this is important to define this up front. You say AI to maybe somebody who's not in the everyday world, in the IT world, and we think chat GPT, we think perplexity, prompts, things like that. Explain to us how AI is used in other senses and in other manners with the IT world.
Yeah, for sure. And so there's actually kind of three different types of AI. So when I talk about AI, and I use the term intentionally, I kind of use it sloppily because that's how everyone else uses it. But there's really kind of three different types of AI that we leverage on the plant floor, right? And so all of industrial AI is going to fit into one of these buckets. So let's run through these three buckets. So the first bucket is what I would call traditional AI. And I know it sounds funny to use the term traditional in an industry that is just now kind of starting to use AI, but the reality of it is that the algorithms in this traditional AI bucket have been around for 10, 15, 20 years and have actually been in use on the plant floor for a while. And so in that bucket, then there's some subcategories. So that's going to be anomaly detection. So that's where we can hook up an ML model to the plant floor. It will start monitoring the state of everything, and then it can tell you when things are going abnormal.
Like
So it'll
in
identify
vision
what
systems and things like that.
vision systems, yeah, as well as we can just model, we can actually monitor just the process parameters themselves, set points and measured values, and it can tell you when things are going abnormal. Now, importantly, it can't tell you why they're going abnormal. All it can say is this looks different than it did yesterday. So that's anomaly detection. That's an important type. And then you have all the predictive types. So this is going to be predictive quality, predictive set point, all of those predictive models. So that's where we take large volumes of very clean, very correlated data, and we send it into an ML model and we train it to predict a single value. So in the case of predictive quality, what's the final quality of this batch going to be by the time it's done, right? Predictive set point, what's a better set point that I should change this to? Predict for me what that better set point is that I should move to versus the one that I'm set to today. And then, of course, you got the computer vision, as you mentioned. We do a lot of stuff, but computer vision in particular has advanced over the last couple of years. And so we actually can do a lot more with computer vision than what has been done in the past. All of that is traditional AI. That's what I would bucket as traditional AI. It's been around, it's proven, and we still do a lot of projects in that space,
Okay.
right? The second primary category is autonomous AI. Now, autonomous AI is unique in that it was built on a whole different platform. So it's built on an algorithm called deep reinforcement learning. Now, if you remember, around 2016, there was this company called DeepMind that spun off of Google, and they built AlphaGo to play the game of Go, and they beat all our grandmasters at Go. And then they built AlphaZero to play chess, and they beat all our chess grandmasters, and then they beat all our best chess software with this AlphaZero. And that algorithm that they discovered is called deep reinforcement learning, or DRL. That is a whole different thing. It is the only AI algorithm that's been proven to understand causal connections and can actually build and activate on long-term strategy. So it can, like a human, imagine to be able to beat a human grandmaster at chess. It's not enough to just plan out all the moves. I mean, we got plenty of software that can plan out, all the moves. It actually has to build a strategy and then adapt that strategy as the real world, dynamics kind of come into play. So that's DRL, and that's autonomous AI. Autonomous AI is very unique in its ability to actually capture human expertise. So we're actually teaching it so we're sitting down with those expert humans, those SMEs who know how to run that part of the process the best. We're sitting down with them and we're actually capturing that expertise in autonomous AI. And then that system can be a decision support system that looks over the shoulder of a novice operator, just like you would if you could put that 24/7, put that expert over their shoulder, and it'll say, hey, I think you need to do this. I think it's going to make recommendations. Do this, make this change. And if that novice operator works themselves into a problem, the autonomous AI can actually map a plan to get him or her out of that bad situation and get back to making on-spec product.
Wow.
So that's autonomous AI. The last one, I'll go quick through this one. That's generative AI is the last category. Generative AI is an umbrella term that includes all the LLMs or large language models. That's going to be ChatGPT, Grok, as well as all the image and video generation. That was built on a different technology called transformers. That was the underlying ML innovation that made generative AI possible, was this technology called transformers. And while we are exploring generative AI on the plant floor, my recommendation actually, which runs counter actually to what a lot of people are saying, is I'm kind of saying we need to kind of hit the brakes on trying to use generative AI on the plant floor. It's got some very serious limitations, and those things, it's fine to use, if you're using it to generate a marketing blurb or something, and it says something crazy, like that could be funny and you just go and you fix it and it's no big deal. But on the plant floor, the stakes are much higher, and we can actually lead to loss of assets, loss of equipment, loss of property, and worse, of course, would be loss of life on the plant floor. So my recommendation right now is to keep it away from the plant floor. Use it in the carpeted spaces in the manufacturing facility to solve knowledge problems, but we really should not be putting generative AI in a situation where it's being asked to solve operational problems on the plant floor.
So is that more the autonomous AI that would be the function of the autonomous?
Exactly. Use autonomous, right? Use the right AI for the right purpose. So autonomous AI can do that. It can solve operational problems. So let's use that and then use generative AI to solve knowledge problems where appropriate. But operational problems are in the realm of autonomous AI. Yeah, exactly.
Have you read any Gary Marcus? Ever heard of him?
I don't know.
Yeah,
I did
okay.
something there. Yeah.
He's kind of a AI skeptic in some degrees, and I think you'd really like him. He gets
Okay.
way into the weeds much more than I can
I'll have to check
clearly
that out.
articulate. But I think one of his points with AI is this idea that we're trying to get to this point where the AI can reason like a human and make all these connections like the human brain can. And he's big on these LLMs saying pump the brakes, like they can't reason that well.
Right.
They cannot make the connections that humans can. Um, I would be curious, how is autonomous AI? It seems like it can, but
Hmm.
I'm assuming it's because it's been given all the parameters and it can, and
Yeah.
within a confine, it can make some of those judgment calls.
Yeah, so autonomous AI is different. It's the combination of two things. It's the deep reinforcement learning, which is a algorithm that specifically is able to make those connections and build those causal understandings. But then also, whenever we do an autonomous AI project, we have to have some mechanism of simulation. So that's how it plays, right? So the way that Alpha Zero was able to learn chess was they literally gave it the rules of chess and then they let it play against itself until it got really, really good.
Yeah.
By the time it was done, it was like it had played 100 human years of chess. So
Right.
we're able to do that same thing. These autonomous AI agents train for about a day, but they train very fast. By the time they're done, it's like they've worked for 20 or 30 years in the plant.
Right.
So they've captured that much expertise, and they've done all kinds of crazy things and made all kinds of mistakes, but we penalize it for mistakes and we reward it as it moves closer to the right operations. And so then it learns over time what is the most optimal way. The other thing that's really interesting though about autonomous AI agents is that they've been shown to be able to generalize solutions. So even if it didn't see that very specific situation happen in its training, like a human, it's able to generalize other things that were like it that it did see and then find an optimal way out. So again, if we go back to its origins, when it was playing chess against human players, those human players had their reputation on the line. So they were going to throw every crazy thing at them at the Alpha Zero that they could, and yet it still was able to beat them.
Right.
So even in the face of novel situations, it's able to find an optimal path out. Generative AI can't do anything like that. As you mentioned, generative AI has been proven not to be able to reason. Apple actually released a study in October of last year, which really should have gotten much more press, I think, where they did a study and they basically proved definitively that generative AI cannot reason really out of a paper bag. So, yeah, generative AI will always need augmented with a reasoning engine, and autonomous AI is that reasoning engine. So that's really what we're saying the future of AI will look like, including industrial AI,
Okay.
is really a hybrid multi-agent approach that will combine the best of both worlds. So you'll use the generative AI for the human to machine interface, then you'll use the autonomous AI for the reasoning and the strategy.
I got it. Great. Well, thank you for that explanation. That was very helpful. Um, let's talk a little bit. I think we're at the point in the conversation when you start talking about the autonomous AI and what it can do. It's the scare the S out of people point in the conversation where you're like, where's the human going to fit in? So, really, I think one of your main points was about how to balance this automation and the AI with the human expertise to unlock the real value from AI. And if you can give us the 10,000-foot view, what do you thinking right now where with the way where we're at with AI and the balance between machine and human?
Yeah, it's a really important question. It's one of the most common questions I get, right? So I tell people what I do and they go, oh, so you're putting people out of work.
Yeah.
It's the exact opposite, right? So one thing that people don't understand who aren't in our industry is the manufacturing industry actually is short on people. So the last number I saw from the Bureau of Labor Statistics was something like a 500,000 person shortfall in the United States. Globally, it's much, much bigger.
Right.
They are losing this expertise. They're losing these people. And the new workforce coming in, and I don't ever want to say anything disparaging about different generations, it's just different. The new generation coming in, they're just not that interested in spending the next decade and a half learning how to run this equipment. They tend to stay for short periods of time. And I'm hearing this from all my clients across all the different industries we serve. I mean, this is true for everything from life science to metals making to mining to everyone is saying to food and beverage. Everyone's saying the same story, is that the folks who knew how best to run the plants are leaving in droves. These are primarily baby boomers.
Right.
The folks that are coming in, they're like, we've got 6-month, 1-year turnover on these guys. They don't stay for very long. They just don't want to do these jobs. So it's not a question of putting people out of work. These companies can't find enough people. They would just throw bodies at it if they could. They can't.
Right.
And so they're looking to automation and AI to augment those people. And so we're not looking to put anyone out of work. That's not the goal here at all. What they want to do is they want to be able to have a novice operator that can run that part of the plant as well as that expert operator used to be able to. So
Right.
all we're trying to do is build a system that can look over their shoulder, make recommendations, and help them to run the equipment. I've got no customer right now that is looking at building completely closed loop, human out of the loop types of things. There's too much risk there typically anyway. That's not really a goal of these types of projects. I know that that's what it sounds like, but it's really not.
Right.
And so when we talk about autonomous AI, it's really the autonomy comes in its ability to leverage that human expertise and that and be able to work out of problems and be able to advise and get better outcomes from somebody who maybe only has a couple days of training on this piece of equipment.
I always find too with technology in general, whenever you bring something new in to make something easier, all that means is you're going to generate that much more productivity and get that much more work. More work is going to actually occur as a result.
That's right. I mean, maybe with one of these autonomous AI systems handling kind of the nitty gritty and the minor moves and things like that, you now can have a human who can run 3 lines instead of just 1 line, right? And we've seen that with customers. So like that, yeah, that's when you're looking at a diminished workforce, like that's what you need is that ability to multiply that value, that human value. But humans bring so much to the table that AI, I mean, I know there's a lot of talk about artificial general intelligence being around the corner, but I've been in this technology space for my whole life, and they've always said we're 5 years, 10 years from, like, same with like nuclear fusion, like we're always 5 years away, 10 years away from nuclear fusion. It's the same way with AI. And I really don't even think we're that close. So we'll need humans for a long time still.
Well, I'll tell you what, if we don't get the nuclear fusion soon, we're not going to get anywhere close on the
Right.
artificial
The
general
energy
AI.
needs of this AI is
Yeah.
significant for
Yeah.
sure.
Let's talk a little bit about high impact AI use cases where the use cases lead and technology follows. And I think you probably can talk about some of the RoviSys applications you've
Yeah.
had.
Yeah, for sure. So we've got a lot of different AI use cases that we've done, and we can talk about a couple of them. But before we get into some specific use cases, I think you mentioned something there that I think is really important. So our philosophy has always been that use cases should lead, technology should follow. A lot of these projects we get in there, and the customer is already thinking about specific technology and platforms, and they want to just we need AI. Well, okay, but what do you want to do with that
Yeah.
AI, right? What do you think it's going to accomplish? Because in a lot of cases, the expectations don't meet reality, and it's not going to be able to do what you want it to do. So first, it's a matter of kind of grounding that discussion, and then we typically go through an exercise where we help them generate AI ideas. And these project ideas, then we'll generate 20 to 40 project ideas. Some of them aren't even AI. It's like, actually, that's just some visualization and some standard analytics. We can do that project tomorrow. So, but then some of them, of course, are AI. And so then now that we've got that big list, we typically downsample that down to what's the low hanging fruit, right? So we need a win. Everyone around the table needs a win with this AI stuff, right? To get everyone bought in. So what's something that we can hit fast, hard, and get done very quickly and show some decent ROI, right? At least a 12-month payback, if not less, right? So let's hit that hard. Now, if we look at specific examples, I can give you some specific examples. So I've got a customer right now, and so they make glass bottles, and they had an issue where they were creating this brand new process to create glass bottles, state-of-the-art process. This process has not changed much in like 100 years. So they were creating this whole new process. And the problem was that it ran well, but it required an expert operator. And they're like, well, that's a problem. We can't put an expert operator in every single one of our plants and expect a 20-year person there to be able to fiddle with it and get it right. So it was just too finicky, and it required too light of a touch and too much hands-on. And so they were looking at building an autonomous AI agent to control that the minor moves on the process, still having a person there that can monitor it, but have that autonomous AI agent be able to keep it on spec and make good bottles with it. And so that's what we did. So we were able to we built a simulator of that part of the process. We sat down with their experts, we interviewed them, and we do this process called machine teaching. That's where we actually grab all that information from their head and we feed it to the autonomous AI agent, and then we let it play. We let it go against that simulator, and by the time it was done, that agent was actually able to get back to making on-spec bottles 50% faster than even their best experts. Their best experts, if the process drifted, i.e. it started to make bad bottles, off-spec bottles, it would take anywhere from 7 to 20 minutes for their best experts to get back to making on-spec bottles. Our agent did it in less than, on average, it was about 2 minutes, and never took longer than 5 minutes to get back to making on-spec bottles. Now, why is that? Because it's a complex process. There's a lot of compensating moves you have to make, right? If I change this, I got to turn this down, turn this knob up, turn this down. So how do humans get back to making, if they see a problem like that, how do they navigate back to good, right? So they're going to make a change, then they're going to kind of wait, right? And they're making bottles every 2 seconds, right? They're going to make a change, wait, see what that did. And then they're going to change this, move this knob, and then they're going to wait and see. That's not how the autonomous AI agent does it, right? It moves all the knobs all at the same time to coalesce towards the solution. It's already mapped out the most optimal path to get there. It doesn't need to make guess and check. It already is mapped out how to get there. And so that's how it's able to get back to making on-spec bottles so fast.
That's really interesting. Now, you guys are system integrators,
Mm-hmm.
and I'm assuming, like you mentioned before, you don't have any of your own IP. You're going
Yep.
in and working with the machinery that's on the factory floor.
Mm-hmm.
So when you're talking about these autonomous agents, you're having to go in with existing equipment. Kind of give me the big picture of how that works. I mean, are you running into lots of different pieces of hardware and
Oh, for
software
sure.
and things like that?
Yeah, it's one of the reasons why we have to be an independent SI in this world, because I've never been in a plant that's completely homogenous, all one platform, right?
Mm.
Like, it's always heterogeneous. There's all kinds of different vendors there, all kinds of different equipment. As you mentioned, the equipment in this world is typically very, very old, right? 20 plus years I mean, that's young for some of this equipment on the plant floor. So, we're very good at getting all of the data out of that equipment and being able then to leverage it. And then we've got a whole toolbox full of vendors, AI vendors and other types of vendors, historians, all kinds of players in this space where we're partners with all of them. And so we've got a whole toolbox of vendors that we can bring in. That vendor is going to get you 50, 60% of the way there. And then we're going to provide effectively what's your competitive advantage. That's what we're going to build on and customize on top of that to build a single solution that solves that problem. I'll give you an example though about old equipment. I love telling this story. So we've got a steel manufacturer and they've got a generator in one of their facilities. And that generator is so old, it's 100 years old, that it has Thomas Edison's team. It wasn't Thomas Edison specifically, but his team that actually installed that generator, and it still has his signature on the drawings.
Wow.
And that generator is still operating today. So now they have to scale up. I'm not an electrical engineer. They have to scale up the frequency or something like that. But yeah, they're still, and everyone's afraid to touch it because nobody wants to break it. And yet we were able to instrument that machine and pull data out of it. And we've got a modern control system that's controlling that generator. So it's possible to do. And in a lot of ways, we're not the company that's going to come in and say, hey, we got to steamroll. We got to rip out everything that you've got and put in all new stuff. Like that's just not realistic in our world. So we're always going in assuming everything stays, and how can we augment that? How can we grab that information, and how can we do some really cool things with it?
Talk to me a little bit about what this does in terms of all these disparate pieces of equipment that are out there. I know one of the big challenges has always been getting all the data from all these different machines and trying to coalesce it. Is that with AI now, is this suddenly a new opportunity that we have? Is that something that's emerging or not really?
Well, I mean, yes and no. So two parts to that. First off is that we've been out there, I've spent my whole career in the plant floor. We divide the plant into 5 different levels, numbered 0 through 4, because we're engineers. We start at 0. And level 3 is what we call the information system space. So that's where we're collecting data from the plant floor. It's below the ERP and business systems, but it's above the plant floor, right? And I've spent my whole career in that space. And we've been preaching for 20 plus years, gather data. You guys need to be collecting data. When I started my career, we were, there's products in our world called historians. They're time series databases, right? They can capture high frequency data coming from the plant floor. They've been around for a long time, 30 plus years. And, but when I started my career in the early 2000s, we were still educating people on what a historian was. And I remember I was in a customer meeting, and the customer said, why would we ever keep that data? We just throw it out. Right now, it sounds quaint to say that now, but like that was the mindset in the early 2000s. I'm not going to save all this data. What would be the point of it? What would I ever even do with it? But we've been preaching this now for 20 plus years. So there's been a lot of customers that have drunk the Kool-Aid and have installed lots of data collection. So in a lot of cases, we have lots of data to work with. In fact, a lot of customers underestimate the amount of data that we have on the plant floor to work with, that they have been collecting over the years.
Okay.
But we still walk into customers that have not gone that route. And so now they're like, well, we got to start from scratch. And that's okay. So we do what are called AI readiness projects. So that's where we're actually working with them to gather up all of that data and bring it into higher level systems. So in a lot of cases, we've got customers that are like, look, we didn't buy into the whole on-prem data collection thing. And we kind of just want to go right to the cloud. Like, okay, then let's just go right to the cloud with it. We can do that. And so, we're good at being able to gather that data. And then you have to collect it, correlate it, and get it into data sets that we can then leverage ML to actually build those models off of. That's ultimately what we're trying to do with that.
Okay.
But I wouldn't be afraid of it. I know that some people are afraid because they go, well, we don't want to start an AI project because we just don't think our data readiness is there. It's like, well, then start an AI readiness project. Like, let's start there. Like, why would you not do anything? You'll never be able to take advantage of AI if you don't get your data house in order. We're doing more, I would say, AI readiness projects today than we've ever done in our past, where we're doing network infrastructure upgrades, right? Well, we got a bunch of disconnected skids. They're not even we don't even really have a plant control network, right? So let's get all your skids network together. Let's get all your equipment network together. We're doing more of that type of readiness projects now than we've ever done, so that those forward-thinking companies can take advantage of AI.
Is that those levels? Is that the Purdue system you were
That's the
describing?
Purdue model.
Is
Yep,
that
still
getting all
around.
messed up with AI now?
No, it really doesn't.
Yeah,
The cloud kind of broke it maybe a little bit because
yeah.
yeah, but yeah, no, we're still using it. We still use it to refer to things today, and where AI comes into play is AI is being used at different levels within that Purdue model. I'll run through it real quick. So down at the when you talk about actually programming the controllers, these are the fundamental things that have intelligence on the plant floor. They're the things that open valves, close valves, heat up reactors. Those controllers, programming them uses something called ladder logic. The major vendors in the space are building co-pilots that can help generate that ladder logic, right? So you got it there. At the higher level, you've got MESs, these manufacturing execution systems that live in the level 3, these big software systems. There's all kinds of AI that's being introduced into that to make it smarter. At a level, I would say like 3.5, where we're now pulling all of that data together from all, like not just one plant, but now I want all the process data from 10 plants, 15, 40 plants across my enterprise. And you're pulling all that together. We're using AI there to sift through that data with stuff we used to have to do by hand. Now the AI can start to sift through that, find patterns. Oh, you call this machine this piece of equipment this in this plant. I see you actually call it this in this plant, but it's the same machine. It's the same type of machine. We're gonna coalesce that and start calling it the same thing. AI can help with that. And then of course, the top level where we're actually then now we've got this data set. Now we can build these AI models to actually do some really cool things with it.
Okay, thanks for going through that. We're at time here. Do you have just a minute for one more question?
Yeah, for sure.
Okay. I want to just touch on this because it was in the list of things to talk about. But biggest challenge you see with manufacturers face in adopting AI and how to overcome them?
Well, the biggest challenge I would say is the lack the disconnect in expectations management, right? It's not data readiness. Like we can solve that. That's not that hard of a problem, especially for a company like us who's been doing that. It's really the expectations management. I go into companies where they go, well, you can't possibly use AI here because of XYZ, and I point out things immediately where we could use it there, we could use it there, we could use it there, right? So that's basically underestimating the capabilities of AI. And then I go into other companies where they're overestimating the capabilities of AI. They're like, well, we just want Skynet. And I'm like, well, that's not here yet. So trying to manage those expectations again with generative AI, I appreciate generative AI and the leap forward that it took us, in this AI journey. But I do have to work pretty hard to undo some of that expectation around generative AI because these customers think we're going to be able to build a co-pilot that's going to go and run their plant for them, and it's just not possible today. And so trying to manage those expectations, I would say, is the number one thing that we try to do.
Boy, if there's ever a field in need of thought leadership, I think it's AI right now. And Bryan, thank you so much for joining us for this half hour. It has been packed with some great insights. And I think you yourself, to me, define a thought leader in the sense that you can take a lot of these, what seem to be very complicated and complex ideas, distill them down into some very elegant explanations. And they're not simplistic, but you explain things very clearly. And I really appreciate
Well,
that.
thanks, Greg. I appreciate that.
Okay. Thanks again for joining us. If somebody wants to get in touch with you, learn more about RoviSys and what you folks can do, how do they do that?
Yeah, so LinkedIn is probably the easiest way to connect with me. You can see my name there, Bryan DeBois. Just search for that on LinkedIn, or go to the RoviSys website, RoviSys.com, RoviSys, and you can find me there as well.
Okay. Thanks again for joining us, Bryan, and thanks everyone for joining us.